Hello and welcome to my channel. This video is about solving initial value problems, also called IVPs, of first-order linear ordinary differential equations of the form y prime plus p sub x times y equals q sub x. How to solve IVPs? Number one, you need to find the implicit, also known as the general solution of the equation. Number two, use the given initial conditions to solve for the constant C. And number three, write the exact solution. So number one, we'll solve the initial value problem. dv dt equals 19.6 minus 0.196 v. Now first we must write v prime equals dv dt because we need to write our given equation in the proper form. So we'll substitute v prime for dv dt and move the negative 0.196v from the right side to the left side to give us v prime plus 0.196v equals 19.6. Next step, we need to identify p sub t and q sub t So here is the general form of this equation. So p sub t is 0.196 and q sub t equals 19.6. And continuing on in our process to solve, we need to find the integrating factor I sub t. And that's equal to e to the power of p sub t dt. This would be e to the power of the integral 0.196 dt, which will give us e to the 0.196 t. Now to find the general solution, we use the formula I sub t v equals parentheses the integral of I sub t times q sub t dt plus c. Then substitute in our information. Basically e sub t, or I should say I sub t and q sub t. E sub t is e to the 0.196 t times v equals the integral. I'm going to write q sub t first since that's a constant. So it'll be the integral of 19.6 times I sub t e to the 0.196 t dt plus c. So this gives e to the 0.196 times t times v. So this integral will be 19.6 divided by 0.196 e to the 0.196 t plus c. And we'll go ahead and divide all terms by e to the 0.196 t. And this will give us V equals, so those cancel, 19.6 divided by 0.196 is 100. And this will be plus CE to the negative 0.196T. And this is our general solution. Now to find the exact solution, we just need to use our initial value that was given. When t is 0, v is 54. So we'll substitute 54 for v, so 54 equals 100 plus CE. Then we'll substitute 0 for the t. So the power e to the power negative 1.96 times 0. Well, 0 times negative 0.196 is 0. E to the 0 is 1, so effectively 1 times c is c. So this equation is just 54 equals 100 plus c. We subtract 100 from each side. We find that c is negative 46. So we'll substitute that value of negative 46 into the general solution for c, so we can write an exact solution. An exact solution would be v equals 100. Substitute negative 46 for the c. So it'd be negative 46 times e to the power negative 0.196t. This is our exact solution to this differential equation with the initial condition v sub 0 equals 54. Let's solve the differential equation. Y plus y prime equals 2 cosine x with the initial condition y of 0 equals 1. Now this equation is already in the proper form to switch around the y prime. Y prime plus y equals 2 cosine x, because the proper form is y prime plus p sub x times y equals q sub x. So we need to identify p sub x. P sub x is 1. Q sub x is 2 cosine of x. Now we need to find the integrating factor I sub x. I sub x is equal to e to the power of the integral p sub x dx. So this is just e to the integral of dx, and that is just e to the x. Now we set up our region of solutions using the formula I sub x y equals the integral of the quantity I sub x times q sub x dx plus c. And we'll substitute in the values of I sub x and q sub x. So e to the x times y equals the integral of 2e to the x cosine x dx plus c. Now, this integral of 2e to the x cosine x dx needs to be done with integration by parts. And integration by parts is integral u dv equals uv minus the integral of v du. So for this first round, I'll let u equal cosine x, so du is negative sine x dx. So that means dv is equal to 2e to the x. So v is dx. V equals 2e to the x. And we'll plug this into the integral. So the integral of 2e to the x cosine x dx equals u, which is cosine x, times v, which is 2e to the x, so that's 2e to the x cosine x minus the integral of v du, so that would be negative 2e to the x sine x dx. And initially, this will become 2e to the x. I want to simplify those two negative signs. Plus the integral of 2e to the x sine x dx. So with this, we have to do integration by parts again. So I'll let u to equal sine x. Du will be cosine x dx. dv equals 2e to the x dx. V will equal 2e to the power x. So this integral, remember the integral of u dv equals uv minus the integral of v du for integration by parts. So this will equal u times v is 2e to the x sine x minus the integral of v du. So minus the integral of 2e to the x cosine x dx. Now, if memory comes to light, that's what we started with. So let's write out all the results so far based on what we've obtained. We started out with the integral of 2e to the x cosine x dx, and that was equal to 2e to the x cosine x plus 2e to the x sine x. And here we have minus the integral of 2e to the x cosine x dx. So let's get rid of all these 2's. So it's the integral of e to the x cosine x dx. In other words, every term we can divide a 2 out of, so I'm just going to get rid of them. Equals e to the x cosine x plus e to the x sine x minus the integral of e to the x cosine x dx. Now I can add the integral of e to the x cosine x dx to get all that on the right. So that will give me 2 integral e to the x cosine x dx, which is what I need. So I'm needing to find out what this integral is, so we'll just solve for it. Equals e to the x cosine x plus e to the x sine x. So let's divide both sides by 2. So the integral of e to the x cosine x dx is 1/2 of the quantity e to the x cosine x plus e to the x sine x. And just add on plus c. And we're just about to finish this up. But this is the integral part of the right side of solving this differential equation. So what we found out by doing this integration work through integration by parts is that the integral of e to the x cosine x dx equals 1/2 e to the x times cosine x plus sine x plus c. Now we need to set this equal to, remember this is equal to I to the x times y, and I to the x was e to the x. So e to the xy equals 1/2 times e to the x times the quantity cosine x plus sine x plus c. Now we'll divide all terms by e to the x. So it gives us y equals 1/2 times the quantity cosine x plus sine x plus c e to the negative x. And this is the general solution. Now, we know that we were given an initial condition y of 0 is 1, so we'll substitute 1 in for y. Everywhere we see an x, we'll replace it with a 0, so 1/2 times parentheses cosine 0 plus sine 0 plus c e to the negative 0 is just e to the 0, or 1. So I'm just going to cross that out, and then this just becomes 1 equals 1/2. Cosine of 0 is 1. Sine of 0 is 0 plus c. Or basically, we just solve the equation 1 equals 1/2 plus c for c. Subtract 1/2 on both sides. C is 1/2. So we'll substitute 1/2 in for c into the general equation, or general solution, and that will give us 1/2 times cosine x plus sine x plus 1/2 e to the power negative x. Now, notice this 1/2 is in common, so I can say y equals 1/2 times the quantity cosine x plus sine x plus e to the power negative x. This is the exact solution to this differential equation. Please look for future videos on solving problems in mathematics, physics, and chemistry in the future. Thank you.